Hi friends, welcome to the Unit 5 Day 3 notes. Now we're going to solve systems of nonlinear inequalities. Most of you have done this before. This is usually a topic covered in Algebra 2. The only thing that's kind of different is now we're going to be introducing circles. So the examples that I'm giving are specifically over including a circle as well. So for this first one, this is a circle with a center at the origin, so 0, 0. Again, you would take the opposite of the signs to find a center if it moved left or right, and then if the y value moved it up or down. And then this has a radius of 5. So by quickly graphing this, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 3. And then this part here tells me that I'm going to have a dashed line, because it's not equal to. So when I make my circle, I'm just going to create this dashed line part that goes around. Not my best circle. And then now in terms of shading, this is actually going to be shaded on the inside. The way you can check is by using a test point. A good one to test is the origin 0, 0. And by quickly plugging in 0 for both x and y, substituting that in, you can see that 0 squared plus 0 squared is in fact less than 25. So that would be true. So we would be testing towards the center, so that would be shading the inside. I'm actually going to hold off on shading. I'm just going to mark off to the side that we're shading inside the circle. That's going to help me when I shade the final part. For this next one, it's a line. I'm going to go ahead and put it into slope-intercept form. So I'm going to have 2y is greater than or equal to x plus 5, divide by 2 on both sides, and we get y, excuse me. We get y is greater than or equal to 1/2 x plus 5/2, so 2.5. So that's going to be here. Let's see, up 1 and over 2 is going to put me here. So it looks like I'm doing something like this. And then continuing on. This does have the equal to part, so when I connect it, I'm going to use a straight edge and make a solid line, like so. And then again, checking a test point, if I check 0, 0, I get 0 is greater than or equal to 2.5. That's false, so you would shade away from that. So this is shading above the line. So then my final shading area is this part right here, because that is both inside the circle and above the line. So any point found within that region is a solution to both systems of inequalities. For this bottom one, similar idea. So again, we have a circle. Its center is at the origin. So its center is at 0, 0, 0. And its radius is 3. The next one, let's go ahead and subtract 2x on both sides. And you get y is greater than or equal to negative 2x plus 5. So for the circle, 3, 1, 2, 3, 1, 2, 3. Again, it's dashed. Like so. And then this is actually outside by checking 0 plus 0 is not greater than 9. So you would shade away from the center, so that would be outside. So I'm going to put the word outside just to remind me. And then now graphing the second, the line, 1, 2, 3, 4, 5, down 2, right 1. And then this is also solid. There we go. So then combining both of these, this is shading above and outside. So it looks like it's just outside this area here. I shade off the graph because a lot of students just think that the grid is where the graph stops. Remember, this goes on forever. So it is all of that area outside there. That is example 5. Join me as we go over the word problems. We'll be doing that part in class. So I will see you then. Bye, friends.